All right, we're live. Got Oliver and Michael here. We're about to do a debate. So I up here in the title, I have it saying plant-based versus carnivore, heart disease and health. So this is not an official title. This will be covering many aspects of plant-based versus non-plant-based things and cholesterol. And anyways, within these opening statements, if you guys want to point out elements of what your positions are, that'll be great. If anybody wants to put any questions in the chat, at the end of the debate, we might be able to get to those. And if not, then we might do a second talk where we get to those. Okay, so we're going to do short opening statements, 10 minutes or less. And Oliver, go ahead.
Yeah, mine is going to be very short. I'll just start with saying that the evidence that that saturated fat causes heart disease is often based off of insignificant associations and bad data. What I mean by bad data is that, for instance, food frequency questionnaires is the most frequent way we gather dietary data on the participants, which is highly inaccurate and could lead to different results than we would expect if the data gathering was perfect. I also didn't prepare an opening, so I'm kind of just winging it a bit. And also say when we get a bit more specific, so it's not like we see high meat eaters and they have X amount of heart disease, and we get more specific, like people who eat butter, which was one of the examples I brought. Butter specifically, when eaten in high dosages, doesn't show any association and sometimes shows benefit. And then there's also some critiques I have of the studies that Michael made or brought. I think we can get into that in the debate, and I won't use much more time here in the opening. Yeah, that's
all right. Sounds good, Michael.
Cool. Is screen share enabled, Carson?
Yeah. I think if you go to share it, it'll just ask me to allow it.
Okay, that should have requested something. Okay. What are you seeing right now? Sorry.
Just your desktop image. It
looks
my
like bad.
Blue Mountains.
So if I do this, that should come up.
There we go.
Okay, cool. Yeah, all right, thanks. So my position, and this is, by the way, the mainstream position in medical literature, and that's that there's many potential ways to eat a healthy diet, but a diet that is high in red meat or a diet that's high in saturated fat beyond a certain threshold of calories will be less healthy than otherwise, depending on the replacement. So when we're talking about health, we're usually looking at endpoints like mortality or death, but we're also factoring in things like heart disease, cancers, and other things as well. I think Oliver and I have sort of loosely agreed to mostly focus this discussion on the endpoints of mortality and heart disease, as they're the most relevant in this discussion, but like there are other things that factor in. We're just kind of mostly focusing on those endpoints. So to give some quick reference ranges as to my position, LDL below 70 milligrams per deciliter is essentially where risk disappears. And red meat, both processed and unprocessed, is linked to cardiovascular disease, colorectal cancer, and mortality. And risk is seen materially around 100 grams a day of unprocessed meat or more. Saturated fat increases LDL, or LDL is sort of it's causal, but ApoB is the more specific, is where the scientific consensus is on direct risk factor. So ApoB and LDL are very, very tightly correlated. But when I say LDL, I'm basically meaning ApoB. But a lot of the research has to do specifically with LDL. So I'm meaning ApoB, but a lot of the stuff that I say is LDL. So I'm just giving you a heads up. Whoever's typing, that is coming through on the mic.
Oh, sorry.
Yeah, I'm just letting you know that's coming through. Yeah, and so as saturated fat increases, ApoB, and risk increases significantly around a threshold as you cross kind of the 8 to 10% of total calories. So, okay. That typing's still coming through.
Oh,
So,
Oliver, Oliver, I'm just going to mute you. I don't know if you have the ability to mute yourself, but with you muted, you can type all you want.
Because it is, I think it's on the wrong audio. Yeah.
I think. Can you hear me now?
Oh yeah, that
Oh,
changed.
yes.
Yeah.
Better. Okay.
Okay, and now you have the ability to mute
I
yourself.
wonder if my mic is on the right mic too.
Okay.
I'll check it after. Okay, so first off, I don't think either Oliver or I would disagree that heart disease is the most common cause of death, slightly edging out cancer. I don't think there's any disagreement there. And we know that ApoB causes heart disease. We know this from many, many human outcome studies, from Mendelian randomization, which is where we look at the genes that cause you to have like certain higher concentrations of ApoB or LDL. We look at it through there. We can also see it through randomized control experiments and metabolic ward experiments. We also know that saturated fat raises ApoB, and red meat contains, I missed a line. We know that red meat raises ApoB depending on the replacement, and we know that saturated fat raises ApoB, and we know that red meat contains more saturated fat than many of the things that you could replace it with. Then what we can do is we can sort of validate this inference, and we can test, and we can look at if you reduce your saturated fat intake below the threshold, that 8 to 10% of calorie threshold, your risk of heart disease goes down. And if we zoom out to the big picture and we look at diet trends, we can see people who eat more red meat are more likely to have heart disease, and we see people who eat more legumes, vegetables, whole grains, healthy fats. They're less likely to have heart disease when calories are held equal. So I'd like to go through this step by step. I have basically what I've done is I have cited a reference for each arrow in this diagram. I don't know the best way to do this. Like if you're going to want to go into each study, I can go through them all right now fairly quickly to just build the inference, but we can also go one at a time. What do you guys prefer?
I can say, for me at least, the thing about saturated fat increasing LDL in the blood is irrelevant for me. I'm just going to grant that, so there's no need to go through that. I think the main dispute we are going to have is basically if there's significant evidence to suggest that red meat or saturated fat is causing these problems.
Okay. Do you grant that ApoB causes heart disease?
Not necessarily, I think.
Okay.
Yeah.
So let me present the evidence, and we can go. I'll try to go quicker through the evidence for the causal link that you're granting, the saturated fat to ApoB. Did you say red meat raises ApoB as well? You grant that?
Yeah, sure.
Okay. So I'll try to go quicker through those, and I'll spend a bit more time on the ApoB to heart disease, and then the outcome data showing the longer arrows in this diagram. So okay.
And just to check, Michael, the papers you're going to be going through to point this out are not papers based on questionnaires, which is Oliver's concern about the studies.
I'll get to that.
Okay.
Yeah, I'll get to that. So, okay, first reference here is it's from the European Heart Journal, and this is it's a consensus statement from the European Atherosclerosis Society consensus panel. And what we see here is just multiple lines of very strong converging evidence, all leading to the same conclusion. So you can, if you hate food frequency questionnaires, fine. There's Mendelian randomization, there's RCTs, there's meta-analyses of all of these things. all pointing that LDL, or more specifically ApoB, causes heart disease. Their criteria for causality is outlined here. I'm not going to go through it all in this, but I wanted to show you this diagram. This is just showing that there is an incredibly strong log linear relationship between exposure to LDL-C, that's LDL cholesterol, and heart disease risk. That's on the y-axis is heart disease risk. And you can see the 3 lines. The red line is randomized control trials. The gray line is observational research or prospective cohort studies. So that's where food frequency questionnaires come in. And then the blue line, is Mendelian randomization. And the reason for the 3 different slopes here is because of the time of exposure. So you can see that there's not only an association with the amount of cholesterol reduction, but also with the time of exposure. Because Mendelian randomization, that takes place over somebody's entire life. A prospective cohort is generally years or many years, and a randomized control trial is usually a short intervention followed by a follow-up of like 3 to 5 years typically. So we would expect to see that the lines increase in slope as it's kind of the temporality increases. Next thing here I wanted to point out is this. So this is data from randomized control trials, not food frequency questionnaires, where LDL was lowered through statin interventions. And we can see that when we lower LDL, when we achieve certain lower amounts of LDL, the risk drops. So again, the achieved LDL is along the bottom and the risk is along the side. And so you can see as it goes lower, it is a very strong association with the risk going down. All right, so that is the reference for citing ApoB causing heart disease. The next reference here, and we can go through all these if you have issues with them. I know one of the papers you cited, Oliver, goes into the to that consensus statement. We can talk about that.
Yep.
So put a bullet on that. The next reference here is the Bergeron RCT. Carson, you're certainly welcome to share all of our references. You can even share that Google Doc link if people want to go into all of this when they're watching it after, or you can share it in the chat now if you want. So yeah, I'm not sure if this was really in question anyway, but this randomized control trial, what it shows is that when we control for macronutrients, so like when we control for saturated fat, when we control for BMI, when we control for other risk factors, we can see that red and white meat still raise LDL more than other diets. So LDL cholesterol and ApoB were higher with red meat and white meat than with non-meat, independent of saturated fat content. I know you're not disputing that point, but I just wanted to point that out in case anyone in the audience doesn't agree. Next one here, I'll go through this one pretty quick as well. So this is the Clark meta-analysis from the notes. This is a meta-analysis of 395 metabolic ward studies where they isocalorically replaced complex carbs with 3 alternatives. So they're going from like good carbs, like the whole grains and so forth, to 3 things. They did saturated fat, they did red meat. Where is it? I lost my spot. Red meat, PUFAs, so polyunsaturated fat, and MUFAs, monounsaturated fat. So if we go to figure 1 here, we can see that, again, there's a strong association between saturated fat increase and blood cholesterol. And if we go to figure 2, I'll click on this to make it a bit bigger. But so remember, we're replacing complex carbs with 3 food groups: saturated fat, poly, and mono. So when they replaced it with saturated fat, LDL went up. When they replaced it with PUFAs, LDL went down. So PUFAs actually, in this trial, showed that they're actually stronger in reducing LDL than complex carbs. And for monounsaturated fat, like olive oil, the LDL impact was leaning towards increase, but still not statistically significant. And then last thing from here, you might have noticed when looking at these diagrams that it was total cholesterol, which is a correlate for risk, but it's not as strong an association as with LDL or ApoB. So they did do stratification for LDL impact, and it was the same sort of trend. When we look at saturated fat, it went up. When we looked at polyunsaturated, it went down. And we looked at monounsaturated, it went down slightly from complex carbs. So again, this just shows that saturated fat raises ApoB. I think you granted that, Oliver.
Mm-hmm.
Okay, so this is one of the big ones then. And I'll go through this quick. If you want to go through this in any more detail or ask questions about it after, we can. But this is the Hooper meta-analysis from the notes. So this was a meta-analysis that pooled 15 randomized controlled trials. Again, not food frequency. This is RCTs. Over 56,000 people. And it looked at reducing saturated fat and replacing it with three things. So carbohydrates, monounsaturated, and polyunsaturated fats. So if you look at the main results section, the included long-term trials suggested that reducing dietary saturated fat reduced the risk of combined cardiovascular events by 17%. And the meta-regression suggested that a greater reduction in saturated fat resulted in a greater reduction of CVD events. So next thing I want to show you from this is the figures and tables. So I mentioned the 8 to 10% threshold. This is where that comes from. So if we focus on the gray and the orange line, that's cardiovascular events and cardiovascular mortality. That's kind of the two bigger endpoints we're talking about. So you can see that there's a huge jump in risk as you cross, this is the percent of calories from saturated fat along the bottom. So as you go kind of between the 8 and 10 is where the risk substantially increases. So if we're ever looking at a study where the intervention, like if a study, the intervention showed it went down from 15 to 11% of calories, for example, we wouldn't expect to see a huge decrease on risk. We want to look at studies where it crosses this risk threshold. Okay, analysis. Oh, sorry, I closed that. Where was it? Figures and tables. Okay, analysis. I think the best way is 3.4. Okay, so here you're looking at lower saturated fat group and the higher saturated fat group. Again, this is showing that you accepted this point, but this is just showing this is a meta-analysis of RCTs now, and it showed the same association that the lower saturated fat group had lower LDL. And then if I go to 0.48, oh, it doesn't. Oh, here we go. Okay. So this is again showing, how do I zoom in? This, okay. So this shows sort of the amount of the replacement. So we're talking about replacing the saturated fat calories. And when we replaced only 1 to 4% of calories, it was a weak association. But when we replaced 4 to 8%, we could see a statistically significant reduction. And same thing when we replaced over 8% of calories. It was only one study, but this is a freaking amazing study. And it showed as well a statistically significant risk reduction in CVD. So basically from this, we can see that as you replace more calories from saturated fat with polyunsaturated fats or other like healthy fats, we see a reduction in risk in cardiovascular disease. And for the last association, this is in the notes, the Zhang, I'm not sure how to say it, cohort. So this is prospective cohort data. So this does include food frequency questionnaires, but validated food frequency questionnaires. So a validated food frequency questionnaire means that they're doing something to validate it. So sometimes what they'll do is they'll do like a pre-screening where they ask a bunch of questions and then see how well the answers to those questions correlate with biomarkers or with actual intake. And then that's how they know that the questionnaire actually reflects that it's accurate. There's other ways to do it too, but validated food frequency questionnaire do associate strongly with RCT data when we look at the concurrence between the two. So this cohort study pooled from 30,000 people across 6 prospective cohort studies, and it looks at the associations of processed meat, unprocessed red meat, poultry, and fish intake, all independently, with the associations on cardiovascular disease and mortality. So the reason I included this one is because it looks at the contrast in the exposure. So this is really important because a lot of studies, in particular, if you're looking at Asian countries, for example, where the amount of meat they're eating is like in the high group, it's like 1 serving a week, and in the low, it's like 1 serving a month. This, we're not expecting to see anything, but this one would pool that in, and they'd both be in the low, right? And so now it's comparing the contrast of exposure over 4 quartiles. So if I go to table 1 here, table 1, it's figure 1. So this is just showing the quartile data. And if we look at meat and poultry intake, sorry, I guess I just wanted to show this to show the intake ranges. So meat and poultry intake in quartile 1 is here. So unprocessed meat intake. So we go from 1.3 in the low to like over 5, almost 6 servings per week in the high. So that it's showing like that contrast and exposure across the range. And if we go to the discussion section here, so it says that this study, where is it? Paragraph 5. This study revealed approximately 3 to 7% higher relative risks and less than 2% higher absolute risks of incident CVD and all-cause mortality over the 30 years of follow-up. So again, it's showing that association as you like cross the risk range. And so one thing I just want to point out here as well is that this statement here is based on 2 servings per week as a unit of interpretation. So the association would increase if you go from 2 to 4 servings to 6 servings to 8 servings. This same risk threshold would apply there. That's what they're saying, is that it's a dose response. So 2 servings per week is a very small amount, and there's still like a statistically significant higher relative risk for those hard endpoints. I can show that through some of the supplemental, but maybe I'll leave it there. I also have one other meta-analysis that goes through the same thing. I guess in the interest of time, maybe I can just turn that over for discussion, and we can go through any of the things you want to point out or challenge there.
You can just keep going.
Okay, cool. So, well, why don't I show this first? So figure 2. So this is just showing the outcome data. So when we look at, okay, it's hard to read this if you're not sure what you're looking at, but the models is different adjustment models. So model 2, I think, was the most reasonable one. I can explain why I think that if you're interested, but you can pick whichever one you want. I thought model 2 made the most sense because it wasn't over adjusting, it wasn't under adjusting. But if we look at the risk associated when, that's processed meat. Unprocessed meat is here. So per two servings per week, we can see there's the statistically significant risk increase of 3%. And this is for cardiovascular disease. Okay, and then the last meta-analysis as well. So this pooled 2 really good prospective cohort studies. So both of these, this was the health professional follow-up study and the nurses health study, both had validated food frequency questionnaires as the method of collecting and analyzing their data. And they found that 1 serving of red meat per day led to a 13% in, I was trying to find it in the text here, 13%. Here, yeah, so 1 serving increase of total red meat per day led to a 13% increase for unprocessed meat. Or yeah, so 13% increase for unprocessed red meat for 1 serving per day. And that was for heart disease, that was for all-cause mortality. And then for heart disease, it was 18% right there. So 1.18 means 18% for unprocessed red meat. And if I can show you that in figure 1. So again, what we're seeing is these are the 2 prospective cohort studies that it's showing. And you can see again, that like dose response curve as the amount of red meat that you eat goes up. We're seeing the risk or the hazard ratio or the risk of heart disease go up. And then one last thing on this one. Where's table 3? See table 4 and table 2. Anyone see it? Here. Okay. So if I think it's at the bottom. So unprocessed red meat, here's the different, so food frequency consumption quintiles. So they broke the red meat, so they broke each of these categories. So here's the red meat one into the different quintiles of consumption. And we can see, adjust it down here. Here's the pooled results. So you can see that this is quintile 1 is obviously it's comparing against quintile 1. That's why it is, the risk is 1. And then as you go to quintile 2 and then 3 and then 4 and then 5, there's like there's a bit of a dip around quartile 2, but it like the trend is towards going up towards as the quintiles, the red meat consumption goes up, the risk goes up. And when you compare the 5th quintile to the 1st, it's actually a 36% increase in risk. So yeah, and then I guess I'll share this just super quick because I put in the references and then I'll turn it back over to you, Oliver. But I mostly focused this analysis that I did on why not red meat, because I don't think that plants only is the only way to be healthy. I think it's like there's nothing inherently bad about eating a plant-rich diet. I think that you can also be healthy by eating like a diet rich in fish, for example, and plants. But I do think there's inherent problems with red meat in that they have independent risk factors for raising ApoB, which causes heart disease, and it has a higher concentration of saturated fat by definition, which independentally causes higher risk of causes higher ApoB, which increases your risk of heart disease. And so this is just actually when I put this in the references, I put the wrong link in, and then when I realized I had the wrong link in, it was too late to fix it. But so I meant to put a different one in, but this is fine. It's a huge systematic review and meta-analysis of like a very large amount of cohort studies. I think you would be fair to criticize some of these for having bad food intake methodology, because these don't all use validated food frequency questionnaires. I could have chosen like many different ones that did. We even looked at some like the nurses health study and the health professional follow-up study that I've cited for the other thing, and some of the replacements where we can see the trend towards eating more plants. Polyunsaturated fat, monounsaturated fat had better outcomes. But anyway, this is 76 publications, over 2.3 million people. Sorry, 2.2 million people, and so again, we just see like a very large, statistically significant total effect for reduction in risk for the plant-rich diets. So yeah, I can. I'm not sure how to stop sharing screen. Oh, here. Okay. So
Yeah. Can you just one last thing? Can you you repeat how they validate the food frequency questionnaires?
For nurses health study and health professional follow-up?
Yeah.
I can go and look. I'm pretty sure that it was through a preliminary survey that they put out and validated against that before starting the study. But I can try to look that up if you want. In the meantime, if you want to look at something else, I'll come back to that in a sec.
Sure. So I think the first one I want to tackle is probably the Hooper 2020.
Okay.
So what we can see with that is that in basically all of the outcomes they looked at, there was no association other than the mixed CHD events, or what it was called. And when we look at the force plot for like the different studies they used to say that or come to that conclusion, we can some guy has done an analysis into the different studies, and some of them, like the Oslo and STAR study, did other interventions on top of just reducing saturated fat. So they also reduced refined grain intake and refined sugar intake in those studies. So therefore, we can't isolate saturated fat as being the cause, and therefore those studies should be excluded. And then I'll probably just start with that. So when we remove those two studies,
what you're talking about? Sorry.
Yeah. How do I share the screen? Present. Window. Okay. Let me see here. What's this one? So when we remove these two studies from the results, we get an insignificant 11% reduction.
Okay, which two studies? Let me just take. I can't actually see. Can you zoom in a bit?
It's the Oslo and STAR study.
Sure. And so.
And that's because they did other interventions on top of just reducing saturated fat. They also they reduced refined grain intake and refined sugar intake.
Let's see. Yeah. So. Like what this paper is doing is it's combining a lot of things, right? Like it's looking at, there were some papers that it included in there, like the Sydney Diet Heart, which I think you could reasonably exclude as well, since it was confounded by trans fat. So what it's doing is it had some inclusion criteria that they defined as to what they're looking for to include in the meta-analysis. And then any study that met that inclusion criteria goes in. So we can look at what that inclusion criteria was, and we can look at whether that looked reasonable or not. So they say included trials fulfilled the following criteria. 1, they were randomized. 2, they had an intention to reduce saturated fat intake or intention to alter dietary fats and achieving a reduction in saturated fat. So that was the intention of the study, was to do that. 3, I can share screen if you want to read this while I go also. I need to figure out how to do this faster because it's kind of slowing it down every time I do this. Share screen. Okay. So I'm just reading the selection criteria for studies. So 3 is they compared with higher saturated fat intake or usual diet. 4, not multifactorial. So that's maybe what you're saying is in contention. So we can look into that if you want for those 2 studies, is like if there was more than one intervention, like lower sugar and lower whatever. And then in adult humans with or without cardiovascular disease, but 6, intervention at least 24 months. 7, mortality or CVD morbidity data is available. So which were there was Oslo, and what you want to look at that one first, maybe?
Yeah. So I have the quote here. So furthermore, experimental dieters were encouraged to eat more nuts, fruits, and vegetables, and to restrict their intake of refined grains and sugar.
That sounds to me like a fair criticism of that study. I mean, there's other problems that I have with this study as well, because I think that this was done during a time when like the margarine all contained trans fats, and so or maybe it wasn't. No, this is 1970. That was right around the time, and maybe this was, yeah. So all the margarines around this time all contain trans fat, and so when you're replacing like the butters with margarines, you'd also be getting trans fat. So there's like other things that might have offset it the other way as well. So is your contention that the sugar decrease confounded the data?
Yeah, or it could have a confounding effect.
How would we see that here? Daily food intake of experimental group as measured during the 5-study trial. Experimental group. So they had 51 grams of sugar in the experimental group. Do we have data for the control group, or is that just? Serum cholesterol. So that's at baseline. It seems weird they would have it only for one, but not both there. Diet. Yeah, I mean, I'll have to look into it. I think it's a since I can't like immediately clear that up, I think that's a fair criticism. Like that's the kind of thing you would look for in these kind of things for sure, is like what other factors and would that confound it? Like, I mean, 50 grams of sugar a day still sounds like a lot to me. So it seems as though it's a bit of a stretch to say that like, okay, the fact, like we would have to assume that the control group is eating like incrementally more than 51 grams of sugar such that it would have confounded these entire results from this trial. I don't know, like no study's perfect. I don't know, like I don't know what to say other than like
the main thing I'm just trying to say is that saturated fat was far from the only thing that was changed in quite a few of these studies.
It was the main thing that was changed, and that's why it was included, right? It was the main thing that was changed.
Yeah.
And what did you want to look at the other one as well? What was the other one you brought up?
Stars, I think it was.
Stars. Okay, I don't have the link for that one handy. Do you have it?
I don't have it on me. I can try and find it here.
What was the name or the author?
I'm not sure. I can. I think I might have found it. Let's see.
Yeah, I think I got it too.
Okay, I think it's GF Watts et al. I can post it in the chat here.
Yeah,
I think
got
it's
it.
this one. I'm not quite sure.
Yep. Okay. Where do you want to look for this one?
Let me see here.
Like, to me, it says the
So it
subject
says here that.
Yeah.
So it also describes here that they are also instructed to eat more fruits, vegetables, and starchy complex carbohydrate foods, reduce consumption of processed foods, including cookies, pastry, and cakes, while the dietary guidelines given to the patient call for strictly limiting the intake of meat, fish, and dairy products. Dietary records showed threefold higher DHA intake among intervention subjects, also of key import. I think this was from wait. So yeah, it's basically the same critique as the other one.
Do you have the full text? I can't see the full text for this.
Yeah, I'm trying to find it.
Carson, does your channel sponsor paying to the price to download the study? I'm just kidding.
Oh, I realized I was muted and I made a comment, but my comment didn't matter.
Oh,
I do want to say one thing, just to show that I'm not biased as a moderator, but I'm not going to do anything other than share some facts as a moderator. I just happened to look up while you guys were talking about the added sugar, and a 20-ounce bottle of Coca-Cola has 55 grams of added sugar in just one. And randomly, this slice of carrot cake has 35 grams of sugar in it. So do with that what you will. But I'm just showing some info.
Cool. Yeah, I mean, like, the point is with this is that, like, when we aggregate data for well, I guess what you're trying to say is that when you remove these two studies that you have an issue with, it's no longer statistically significant. Is that what your point is?
yeah, and there's also another trial you could pick holes at, and removing all three would make it even less significant.
What's the third one?
The third one is the Houts-Muller trial.
Okay. Yeah, I mean, even when you remove those three, is it the case that it still, like, heavily leans in that direction? Like, do you have the
It
forest
says
plot
yeah,
recalculated?
the forest plot, the updated forest plot, if you remove those two, is it shows a 0.94 relative risk.
Okay, so
As opposed,
and what's the confidence interval on that?
confidence interval is 0.84 to 1.05.
Okay, so still leaning in that direction.
Yeah, it's definitely still leaning,
Yeah.
but there also you could add more hypotheses to it that's compatible with the evidence, without it having to demonize, for instance, saturated fat for being atherogenic or LDLC. Like, for instance, there's a mechanism which relies upon the oxidative modification of LDL particles for the progression of atherosclerosis. So it's possible that beyond a certain threshold of, for instance, seed oil intake, which has been shown many times to increase oxidative modification of these particles, that in this specific case, it would actually be worse to have more LDL particles, because then there is more particles to be oxidized, which would further progress the disease. But if you're in the case of a diet which doesn't have a bunch of those compounds which would cause such modification, then LDLC would be harmless, or mostly harmless.
Yeah, I mean, we can point to mechanisms until they've been demonstrated in the outcome data, though they don't really mean much. Like, the I mean, I can point to a mechanism here also. If you want to show yours, you're welcome to. But this is the way that we understand this to happen is, I might be able to draw this easier. Basically, when you have LDL in your blood, or ApoB containing ApoB containing lipoproteins, including LDL and VLDL and other ApoB particles, they get trapped when they're of a certain size, under 70 nanometers, I think. So some particles are fine, some are not. The ones that are small enough get retained in the artery wall, and they eventually will oxidize in the artery wall. So it has nothing to do with like consuming like oxidated thing. It's like the oxidation happens just by getting LDL trapped in the artery wall. So it's like, yeah, there's, and the advantage to my mechanism is that it seems to pan out in the outcome data when we look at like the correlation between ApoB and these risk factors, and heart disease. We see that there's an association there, whereas we don't see one when we look at seed oil consumption, for instance, or other things that would indicate that the mechanism you're proposing led to heart disease.
I would say, given some, I can add some more context, but I think my hypothesis would still be compatible. So what I'm proposing is that beyond a certain threshold of seed oil intake, which most of the population would meet because we actually eat a lot more seed oils than we think. Beyond that threshold, then the increase in seed oil doesn't really matter that much. And then the problem becomes having too much LDL, which gets oxidized. So like your case with the saturated fat cutoff percentage. So between 11 and 15%, there's not really a difference, but between 8 and 11%, there would be a difference. I mean, I also have my problems with that one.
Is that are you saying that's your threshold, or you're just using that as
no, it was just an example.
Okay. What's your threshold for seed oil intake?
No idea.
Okay.
I don't think I have enough evidence to say that. It's just a hypothesis which would be, I would say, pretty consistent with the outcome evidence.
I mean, like the LA veterans here, this study, what am I looking at here? What's the primary
That's
outcome?
cardiovascular disease. It looks like.
Usual diet. All-cause mortality, sorry. I wanted to look at CVD. Oh, crap. I don't remember. Was it 1.48 or 1 point? Well, anyway, it doesn't matter. I can show you this actual study. The LA veterans, it was a very significant. This would certainly have crossed the threshold. It was like over 30 grams difference a day or something. Or over 30% of calories, I think, were in polyunsaturated fats, seed oils. And I just want to say this one point. I'll let you respond to that too. But if we're like removing studies out of this, like Sydney diet heart confounded by trans fat, and that is one that leans the other way too. So it's like if you're removing other ones for reasons and kind of picking apart, like I would argue Sydney diet heart shouldn't be included in this because of trans fat confounding.
Maybe.
Yeah.
I mean, I looked a bit into it. It was a long time ago, but I might be wrong. I might be misremembering, but if I'm not completely incorrect, there was also trans fat consumption in the saturated fat group.
Well, less, because the trans fat was coming from the replacement. So you're right, there was some trans fat, but it would have been less.
Okay.
Yeah.
Again, I'm not that specific, so I'm not that familiar with. I have an idea.
Okay, sorry, go ahead.
Yeah, so I think I have a few more points I think we can address right now. There are a bunch of points we've brought up that we haven't looked enough into, like the specific studies to find like the specific quotes for some of the things that I, for instance, gave. So I think we can leave this aside and we can find another time, and I'll be more prepared with the quotes ready, a little PowerPoint presentation, and then we can just move on to, I think, the Mendelian randomization, for instance.
Okay.
Yeah. that fine?
Sure. Yeah.
Okay.
Do you want
So-
to like just put up like our view there in 30 seconds or something each, just so we kind of put a. So I would say like we were talking about Hooper, which was a meta-analysis and systematic review of randomized controlled trials showing the impact on cardiovascular disease and mortality from reduction in saturated fat. My position is that this shows statistically significant association there. Oliver was saying that. Well, I'll let you say your position.
Yeah, my position is that some trials were included, which I think contaminate the results and can't isolate saturated fat as being the cause of the reduction in risk. And therefore, I don't see it as a significant study to suggest that saturated fat causes heart disease. Or saturated fat in and of itself causes heart disease.
All right, cool.
Probably
I've got, I didn't include it in the references, but I have like isocaloric studies that I can bring to the next one too, and we can look at those where it's isolated to saturated fat. But yeah, cool. We can move on with that if you like. What do you want to talk about next?
I have 2 points. So there's, maybe actually 3. But there's a saturated fat cutoff point around the 8 to 10% you mentioned. There's the Mendelian randomization, and I also want to bring up the studies that I showed in the doc that I sent to you about butter.
Yeah,
I'm curious to hear what your take is on how they find either a benefit in heart disease or stroke or other diseases, or just no association at all in the case of butter, even in very high intakes.
Yeah,
so I can screen share if you want. Yeah, I'll screen share. Window. There. So there are 2 studies I want to bring up for this case. So there's this one where they looked at different types of dairy as well, and what they found with butter specifically.
Sorry, what study is this? Oliver, just so I can
this
follow
is
you.
the if I go in the document, it's the one called Dukusimana dairy paper. Yeah.
Okay.
Yeah. Oh, this one. Yeah. So what we can see with butter is that in all these different outcomes, like major adverse coronary event, coronary heart disease, and stroke, we see either a benefit or just no association. And then there's the other one here, which had, I think, 6.5 million person years of follow-up right here. And what they found was a bunch of non-significant associations, like a relative risk of 1.01, 1.02, 1.03. And therefore, they suggested that butter, at least in this study, was not associated with heart disease. And what we can also see with this one is that the grams per day would exceed even that of some people on the carnivore diet. So this is a very high amount of saturated fat and a very high amount of butter every day. So I'm curious to know why you think this is the case.
For sure. Okay, so starting with dairy in general, I don't view it as inherently harmful. I think that low-fat dairy is neutral or possibly leaning even slightly health promoting. So I don't know that I'd necessarily disagree with you on that. I would disagree with you on the butter one. So this one came in a bit late, and I didn't specifically look into on your dairy paper. I didn't look into the association with butter on that one yet. I didn't get a chance. So I'm happy to go through it now if you'd like, just live, or I did look at the butter paper. So either one of those we can talk about.
Just start with the butter one.
Okay.
Then...
Well, all right. So let me get there. Sorry. Okay. So yeah, this study concludes that no or minimal association of risk with butter intake. And it was basing that finding on an an increase in 1 tablespoon of butter a day, right?
Mhm.
Yeah. So how much increased risk would you do you think would be reasonable with something like 1 tablespoon of butter a day in order for it to be meaningful?
For me, it depends on the absolute risk and like the prevalence rates. So, it's hard to explain, but you
Yeah,
know
no,
how if there's a higher prevalence rate, you wouldn't need as high of a relative risk to find a significant association. So with
Mhm.
smoking, it's easy to get into the thousands of percentages in relative risk, whereas that would be impossible with heart disease because there's so many people who get it. And then it's the opposite with absolute risk, for instance. So the higher the prevalence rate, the higher an absolute risk you would need to also show there's a significant association, I would say. And I
Yeah,
would
so
also
I
need to look
mean,
at that.
this paper, it was a very small intervention. So I would take like anything with a grain of salt, because like 1 tablespoon of butter a day seems like a very small amount of total.
It
Like
should be mentioned that
that's
this was per 14 grams, so per 1
for
tablespoon.
14 grams of butter, which is about 7 grams of saturated fat, right? Which is
Yeah.
like, yeah, a fairly small portion of calories that like wouldn't necessarily push your saturated fat like pretty concretely above or below that threshold. And there was a 1% increased risk of death, but as you said, an 8% decreased risk of diabetes. So it seems odd to me that like, since we have all this other data showing that there is an association, even if you take out those papers you don't like, there's still a leaning in that direction where saturated fat is increasing your risk of heart disease. So if you were to want to say that butter, even in spite of its saturated fat content, somehow has a protective or neutral effect, then that could only be explained by all of the other stuff, like the red meat just has an even worse effect. Is that your position, or where do you sit on
No,
that?
what I'm trying to say is basically, I'm just trying to ask actually, why don't we see an association with butter? And it should also be included that the outcomes were based on per 14 grams of butter a day. Just like yours was a specific relative risk per serving of increased meat consumption. This is per 1 tablespoon a day.
Yeah. So, I mean, 1% increased risk of mortality per tablespoon of butter a day sounds not great to me.
I wouldn't say it's. I wouldn't find it significant.
Okay.
With
Well,
a relative risk of.
I mean, it's
1.1.
one food group, right? It's like anytime we're looking at like one thing that's a very small part of somebody's diet, it's always going to be talking in like small absolute numbers. Even small relative risk numbers in a lot of cases, like depending on how prevalent that food is in their diet, which, yeah. So, I mean, to me, it's like if eating a tablespoon of something a day was increasing my risk of death by 1%. I know there's other stuff involved, but like, just if that was true of a food, I would avoid that food.
Wait, I was looking a bit at the study. Can you just repeat the last like 10
Yeah.
words you said?
I was just saying, like, I know there's other factors in that study, but just like, are you in agreement that if there was a food that did nothing else but increase your risk of death by 1% per tablespoon, like, would you avoid that food, or would you say,
Yeah.
it's only 1%? You would. Okay.
Yeah, I would.
Yeah. Okay.
Unless it tasted very good.
Sure.
Yeah. But that.
Because
But
like
that
with this,
1% could
see a
easily
similar.
be due to
Sorry.
chance.
I mean, go ahead.
Yeah. So what I would say is when we deal with such small relative risks, what a lot of it can just be explained by pure chance and inaccuracies in the study, because you would agree that both this cohort study and other cohort studies, you might say they're good, but you wouldn't say they're perfect. I think, because there's no control basically.
Yeah.
I have some other critiques of
Did you want to look at the dairy one also? Like, as I said, I can take a quick look right now if you want, or we can just park it.
I think we can just park it for now. I would love to get back to you, and I'll, as I said, I'll prepare a little PowerPoint presentation
Okay, cool.
and get all the stuff ready. And I just want to get these few points cleared out so I have a better understanding of what your position is. And then we can have an even more in-depth discussion next time. So I think it's fine with the butter stuff for now.
Okay.
The second thing was the saturated fat cutoff percentage you mentioned, and that graph. Yeah, you know which one I'm talking about.
Yeah.
But what I would say about that is that it's very misleading because the study they used to support the saturated fat cutoff was the black study, which had 2 events of cardiovascular disease. So it's a difference between 0 events and 2 events. And I would say that's very insignificant and could easily just be due to chance.
That was from the meta-analysis, the Hooper meta-analysis.
Yeah, Hooper.
Yeah. Hold on, sorry. Okay, I'll pull it up. Do you have it handy, like where you're seeing that?
Yeah, here
Okay.
I can just copy the picture of the table. I hope I can send. No, I can't.
Like what I'm just wanting to see is.
Oh yeah, I have it here. I found that.
Okay.
No wait, I found the graph. Wait, I need to find the forest plot. Yeah. Okay, I can present the screen.
Okay, sounds good. I'm almost
So I'm
there
not.
myself.
So I'm not on like the study. This is just a guy who took it out, but you can check yourself.
Are you able to
also
zoom
showed
in?
this- Yeah, I think so. So this is the stuff here. So there's the black study here. Events in the experimental group was 0, and events in the control group was 2. And this is basically where the saturated fat cutoff point came from. This one they show here. CSD events.
Are you saying that's the only, like there's other studies in this that drop below that threshold? So I don't know why do you think it's only that one? Like the LA veterans, it had a range below that. I know for sure. The Sydney Diet Heart, I can check. I don't remember offhand if it did. But I can look. So like LA veterans had a range below that though. So I don't know what that if that's a blog or something. I don't know what that person's talking about.
Yeah, it's from a blog post.
What did it say about that part in particular?
That the main cause for the saturated fat cutoff in the graph is because of the black study, which included 2 events of heart disease. And therefore, and we can also I can just present.
I don't think that's true.
I can present one more thing. I think I just found it. So we can see here it says the risk ratio here 0.2. This is the one from the black study. And if we go to the graph here, we can see that it's exactly 0.2 here as well, indicating that this is most likely exclusively made from the black study.
Well, let's just look.
This particular cutoff point.
I mean, like I can open up LA Veterans and we can look at it if you want.
Yeah.
Okay. Okay, let's see. I've got too many tabs open now. I'm getting lost. So hold on a sec. Okay. LA.
But I would say that there are also some problems with the LA veterans study.
What problems?
So, for instance, there's a higher number of smokers in the control group, like significantly higher, and less non-smokers. There was also no portion control, and
Yeah.
often the participants could be away from the dump site, I think it's called, for months or years at a time. So there's also, I mean, it's better controlled than other studies, but it's not far from perfectly controlled.
What's the full text here?
And the authors themselves claim that there was no association between individual endpoints, and only in the pooled results did they find an association. But as they also mentioned themselves, it's
Sorry, are you talking about Hooper again now, or LA veterans?
no, this is LA veterans.
What pooled was that? What do you mean pooled? Or adjusted results? Do you mean?
Let me find it here. It's the
Pooled
endpoints.
Pooled endpoints, yeah.
So
yeah.
The quote is, when these data are pulled with data from secondary endpoints, and then some stuff in the parentheses, the modified diet group showed significantly fewer total events and fewer fatal atherosclerotic events. And they themselves then...
Yeah, I mean, it's an RCT, so like looking at mortality is not going to be largely affected. But like what sorry, the link I had is going to a place where I'll have to log in and probably reactivate my trial for when I downloaded this. So I'm not going to be able to find this at this second. This paper is always so hard to get the full text. It's like this. It's like 6 pages like this, and all the data is there. It's kind of hard to extract it. But what I have written from it, if you disagree with any of this, let me know. But they said there was a statistically significant 30% reduction in CVD events, and there was a 33% reduction in CVD deaths in the intervention group.
Can you show where? Do you have like a screenshot of where it says that? Because I have looked through it before, and I haven't quite been able to find that.
Okay, I can try to look. LA veterans. Remember the year? If I can't find this right away, Carson, we can move on from this.
Yep.
So many of these things. Wait, this is. No. Okay.
Yeah, same more Dayton. It should be the right one.
Yeah. I don't know. I'm sorry. I bought a subscription so I could pull this up, but I think it expired.
That's unlucky.
Shoot.
It's fine. We can move on if you have trouble finding it.
Yeah.
Then we can
I have one other note on this. Regarding the total deaths. So the 33% reduction was in CVD deaths. And I think you were saying something that, the total deaths though were like closer to the same, or maybe even skewing slightly in the other direction. And yeah, the authors mentioned this, and they thought that at the time there was, they thought that it might be due to some other unknown toxic effects of the PUFA diet. Which is kind of funny, but as we know now, that doesn't play out in the outcome data. But as far as cardiovascular disease events and cardiovascular disease deaths, there was a reduction in the intervention group of about 30%.
Yep.
Yeah. Where do we leave off? So that was
that's a saturated fat cutoff. Oh, yeah.
Oh, yeah. And I was saying that was likely to be included since they were, yeah. And also Sydney Diet Heart, I don't think they did cross the reference range, actually. Yeah, but I mean, you could look into whether or not that blog, what they said about LA veterans, and because to me, that would have been included in that threshold cross. I know they crossed that threshold. So they
And
should
we can just look at like the forest plot and the graph itself, and we can see like the forest plot says the black study had a 0.2 risk ratio, and the graph showed that the risk ratio was 0.2.
Can I see that?
In that
Do you have that
reference range.
forest plot
Yeah.
handy again?
Yeah. I'll share it. Here. So it is this one. So 0.2 relative risk here.
Mhm.
And
Just leave that there for a sec. I just want to see what the context is there. So what is this risk of what? What are they comparing here?
this is I think it's CHD deaths. Oh wait. It should be here. Relative risk of events. So it's CHD events. Yeah, okay, it says here events as well.
But events could like, is it CHD? Like, do you have
Yeah,
the
CHD event. Or I mean, I have the full study here open, but it's very long. Do you know what figure it is? Then I can find it.
from Hooper?
From Hooper, yeah.
Yeah. Hooper. There we go. Figure. And if you open up figures and tables,
I mean, I have a different like PDF version open.
Oh,
of
I see. Okay, gotcha.
Oh wait, I have the real one. Oh wait, I have both versions open here. Figures and tables. Which one was it?
Yeah. I'm getting a lot of tabs. Sorry, I'm trying to get back to where I can see your screen. Oh, I don't see it.
No, I stopped screen sharing.
It's what are you trying to find right now? Is that the analysis 1.48?
I'm just trying to find the exact the same forest plot just within the study, so we can.
Okay, there's like a million of them. It's gonna be hard to find it. But like the one I was pointing out was analysis 1.48. If you want to look at that one, and then like that's CHD events, and so you can see if that looks the same as the thing that you have the screenshot of.
Comparison one and okay, this one, CHD events.
You're not sharing screen. Just
yeah, I know.
Yeah, it's okay.
Yeah, I'm just looking at it here. Okay, maybe I should screen share. Then you can say what you want to take a look at.
Okay.
So it's here.
Okay, yeah. So this is 1.48. Oh yeah, sorry. This was just showing the differences in exposures. Maybe that's not the best one. I mean, like one of these is going to be just the total. So maybe it is the one that you have screenshotted. So let's look through it. I keep closing it because I have so many tabs open.
Yeah.
Okay.
I had to close my other window of my browser, which has so many tabs that if I open any more, it doesn't load them. It doesn't even load tabs anymore.
So if I type in just we're looking at is it CVD they're saying? CVD events? Or
I think it's CHD events.
Okay.
No, wait, it's CVD events. CVD. Yeah. My bad.
That's good. Oh, it's not even letting me. All cause. So it'd be below this. Cardiovascular mortality. And should be just below that. Here's CVD events. So table 1. So there's combined cardiovascular events, which is 1.35. And then there's it looks like, what's this? What was this study? Black?
Yeah.
It's not
like
even
1994.
I mean, it's on So are you still sharing screen? If you look at 1. If you look at 1.35, 1.36, like this one, it looks like it has all of them. That one, it says the ones that are low risk of bias, which black isn't in there anymore. But yeah, so I don't know where. So we're looking for one that has like only 5, and black is one of the 5, but I don't even see that in all of the CVD events here. Do you?
Nope.
I don't know where that's from. But if we look at just all of the combined cardiovascular events, like this, like black's in there, and it says 0.2. But I don't think it's like just taking point estimates. Like I don't know. Like I think it's a coincidence that it's 0.2 and 0.2. Like because there's like that graph is combining.
Yeah, it's combining different endpoints, but this is specifically looking at CVD events. So you can see there's like all-cause mortality, CVD mortality, myocardial infarction. This is only looking at CVD events. And for specifically CVD events, it would seem that this is the only forest plot they base this specific gray line off of.
I don't think, like, do the other points correspond with the gray line?
So there's 0.8, some 0.79. Which is the Veterans Administration. So that would fit well right here. And then there's between 0.8 and 0.9. I think.
But LA Veterans was not 9% of calories as saturated fat.
No. I don't think that's what it's looking at here either.
But that's, I mean, that's like that graph with the line graph. It's showing percent of calories. So like it's not specific studies. It's showing like as you increase your percent of calories of saturated fat. Yeah, one.
I know energy from saturated fat and relative risk of event.
Yeah, so it's not like each point is a study. It's combining studies that reached a certain percent decrease of calories and then saying what the risk was. So like LA Veterans wouldn't be way up there at 0.79 because it was less than that. It was. I wish I could pull it up and tell you exactly. We did, but I'm positive it was less.
Yes.
I just don't. I think that this person is just like mistaking what these things mean. I don't think that graph, that 0.2. I think it's a coincidence that it's there.
Okay. I think we can move on now. Is that fine?
Yeah, for sure.
There's at least one last thing I wanna just talk about real quickly, and then if you have anything, you're welcome to do that as well. It's the Mendelian randomization. I would say I don't think it's that good of a methodology to kind of isolate LDL as the cause. First of all, there's some underlying assumptions that need to be made. So it's first of all that these SNPs, these genes, these polymorphisms affect the LDL in the way that we expect them to, which they are validated. We know that they decrease LDL from previous studies, which are based off of most often a one-time measurement of LDL cholesterol, and just looking if it's below another population for comparison, like the general public. And it's also important to note that just beyond having one single measurement, LDL is also estimated. It's calculated and not really measured. So there's also some error or uncertainty within that. Beyond that, we don't know if what the actual LDL level was, just what we think it was. So for instance, it could be that some of the people who have a lot of LDL, they are on statin treatment. I know this specific study doesn't look at people with more LDL, but just reductions in LDL. But we don't know if they actually had that reduction. We just think they have.
Sorry?
If you go back to the EAS, I think it is.
Well, no, that had achieved LDL. So it wasn't the reduction, it was the achieved. I can show you.
Yeah.
Hold on. Oh man, I need what's Joe Rogan's guy? Jamie. I need a Jamie. Pull that up. Okay, hold on. Okay, EA. Okay, here it is. And then, God, share screen. I'm trying to find it. Okay. Okay, share screen. Share screen. This one. Okay. 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 So the Mendelian was, or sorry, this was
That's a
this was
statin,
from Odyssey 2
right?
data. Yeah.
Yeah. I mean the one above with the Mendelian randomization.
Mm-hmm.
Yeah. So that's the
Like,
blue
I mean,
line, right? Is that magnitude? Oh, that says magnitude of exposure to LDL.
right.
Yeah.
Yeah. So that's again so it's not the reduction, it's the total exposure. And the reason this is a lower number, I know you would know this, but the reason this is a lower number is there's two ways of like the metric system and the imperial, and this is the millimole per
I'm aware
liter.
of millimole.
Yeah, I'm just for anyone listening who doesn't understand why the numbers keep changing. So it's about two. Is it 2 millimole per liter? Is about 70? Is that right? I think it's about 30, 36.
Yeah, I think that would make a lot of sense. I think. Yeah, that would make a lot of sense if that was the case.
Yeah.
But yeah, my critique still applies that basically this is both what we expect, just what we think is the actual LDL level of the population, or it's based off of one-time measurement, which is estimated / calculated, which also bears some uncertainty.
What do you so okay, we can go through all these critiques one by one. So
it's not all of my critiques. I'm just trying to remember the other ones a bit.
Yeah, no worries. But like, whichever ones you want to say, we can go by them one by one. So the
because that was the one I just said
didn't apply. What was that one? Sorry.
So it was basically
measurement?
Yeah, I can say. Yeah, it's either based off a one-time measurement or it's based off of an assumption from a prior study looking at a one-time measurement.
So, and you're talking specifically about Mendelian randomization.
Yeah. So I can elaborate it if you
understand the criticism. Like,
yeah, I can elaborate. So there are these different genes that are associated with a certain amount of LDL decrease, and that specific LDL decrease is based off of a one-time measurement in most cases. So what we see is where these are plotted is basically where we think the LDL level or the LDL exposure was, but not what it actually was.
That's the hypothesis, is that it's not where it actually was. Like,
that
if you were to take...
it's possible, it's very possible that it wasn't, and also it should be accompanied with the fact that genes react to the environment. So there are so we have a bunch of genes which aren't turned on in the body, and then depending on our environment, those genes might turn on and some others might turn off. So there are a bunch of variability in these studies that can't be taken into consideration.
Okay. So, okay, let's go through that one at a time. So the first one is it's based on a single reading measurement. Yeah. Why would that matter?
Because LDL levels fluctuate like crazy. I mean, as a person who has gotten,
like, if we do enough measurements in enough people and it correlates, like, isn't that like, that's showing that there is a correlation? It's like, yes, sometimes some people will be higher, some will be lower because it fluctuates, and there's dietary things that are involved. But this is just saying, like, are you questioning whether we can even isolate that a gene causes a lower LDL concentration? Or
what I'm trying to say is that Mendelian randomization is not necessarily a better methodology than just normal cohorts. I would say,
A gene.
because there's
Like, sorry,
probably
are you,
just
are
as
you
much
questioning that we
inaccuracy.
can isolate a gene that that results in lower LDL? Are you questioning that, or are you saying there's other genes that might be confounding it?
Oh, that was actually another one. Thanks for reminding me. But I think it's actually both. Like we can't. It depends what you mean by your question, but I can elaborate. So
Okay.
we can say that this gene has been shown to probably reduce LDL on average, but we don't know like to what degree because there's so
I mean,
much inaccuracy.
it's
Like we have an idea, we have an estimate of what we think it is, but
yeah.
not.
I mean, I guess you could get better data if you took more measurements or whatever, but like to me, it's like this line, these plot points correlate really nicely with this log linear graph, and it, like, whether it's one reading or five or like 1,000 people or 1,000,000 people, it's like we're getting some consistent data plotted here, which shows that there's a close association. So and we get a similar kind of close association with RCTs and prospective cohorts. And so, like, to me, it's like, and sorry, so there's two things here. There's one is there's probably better data that I could show about Mendelian randomization with genes correlating with LDL. This is the gene correlates with risk of exposure as well. So we're up, like, we're A to B to C. So it's almost like it's, yeah.
Okay. Yeah. There's some. Oh yeah, I wanted to also, because you just reminded me of it. With some of the genes that increase LDL, they also have an effect on other things like the coagulatory factor. So people who are genetically predisposed to have higher LDL also are at higher risk of coagulation. That was poorly phrased, but
Are you saying it's the same gene that causes that?
Okay, so here,
if it's the same gene, I would just say it plays out in the outcome data, which we see.
It says here that, so it is described to be genetically, so people who have, for instance, familial hypercholesterolemia are genetically susceptible to develop coagulopathy. And there was this other one I had. I'll need to find it.
Like, that's, I mean, it's all factored into the outcome data, right?
No, I don't think you can, like, are you
Like,
trying to
this
say
is
it's
the outcome
adjusted
data.
for it, or?
This is, like, each one of these points is a gene, I think, right? That it's like a different gene that that corresponds to like a magnitude of exposure to LDL. And then,
Okay.
Yeah, go ahead.
Yeah, I found it here. So
okay,
this is a quote from the one I sent. The critical assessment, a critical review of the consensus statement from European Atherosclerosis
you want me to pull
Society.
it up, or?
I can pull it up.
Okay, go ahead.
Here, I'll present. Okay, so there's this one. I just had to find it again. So it says here, therefore, genetic mutations in or near LDLR are expected to affect not only LDL receptor function, but also blood coagulability through the coagulation factors and some other stuff here. So basically, the way, and this also ties into the way familial hypercholesterolemia works. So it's not just that the body produces more cholesterol, but it's actually the LDL receptors actually losing function, so the body cannot utilize the LDL that much, so it gets stuck in the blood, and therefore it has an effect on blood coagulability.
So I am just trying to understand the mechanism that is being speculated here. It's saying that there's another gene that correlates, like when you have gene A, you also are more likely to have gene B, which interacts in a certain way, or what is it saying?
No, it's so if I can if I understand this correctly, it's basically that this gene has an effect on this, which leads to it having this other effect.
Exons is known to be a mosaic of exons shared with different proteins.
Oh, I didn't. I just highlighted something random. There was no. It has no meaning.
Yeah, no, it's okay.
Yeah.
I mean, so it's mechanism, talking mechanism. It's saying that there's some other stuff that's happening. It's like there might be other stuff that's happening that maybe that's offsetting some of the risk reduction that would have otherwise been there, but the risk reduction is there. We see it in the data. So it's like it's all factored in. You know what I mean? Like I don't know what that does to
I mean, it's not like they adjust for coagulation.
They adjust for coagulation?
What I'm saying is that they don't. So if it was the case that, and what they argue the case is that it's very likely that this would increase coagulation.
Would that affect?
If that was the case, that would not be factored into the Mendelian randomization. Like it would not be adjusted for, nor would I think it would be. I mean, I have my problems with adjustments. I think they get you closer to the actual result, but I don't think they get you to the actual result. Like there are limitations to how good adjustments can be and how much you can trust them.
Are you saying, I just want to understand what the hypothesis is here with the coagulation thing. Like, are you saying that so we have EAU says that there's this gene that there's genes we can find that affect LDL and that reduces risk when you have them. This other thing is saying, hey, some of those, there's also likely to be this blood coagulation thing that is not being factored into this risk reduction. Would this blood coagulation thing be affecting the health outcomes in a different way than CHD risk?
I don't know. I actually don't have the best understanding of the symptoms of higher blood coagulability, but I would guess like heart disease.
Yeah, I would guess that too. I don't know for a fact, but like if that is the case, that's like also factored in because we have data on gene is there, LDL is lowered by this much, and risk is lowered by this much. And it's like if there's other stuff going on, that all comes out in the data to me. So if it's saying something different than that,
then that would.
No,
that would challenge the idea that the data shows that it's because of the LDL-C reduction as opposed to some other confounding variable.
Well, I mean, if there's another variable, then it would be possible to demonstrate, like what we'd be looking for is a line similar to this with point estimates that are off because of some other thing, right? You know what I mean?
Yeah, like, I know what you mean. I'm not sure I agree.
Well, yeah, I mean, we can just move on, I guess. Like to me, it's like there's a very clear association where a gene causes lower LDL, it corresponds log linearly to reduced risk of CHD, and that factors in all mechanisms that are going on in the background. It all boils down to this log linear association. So what I'm saying is, if you're saying there's other stuff going on that is confounding this, we'd expect to see that this is not so close as an association, and there's like dots all over here and all over here because of this other thing that's like an artifact in the data. We don't see that, so I'm saying that that's likely not the case. But you can say one thing also before we move on if you'd like.
Yeah, I'll take that into consideration when I prepare for next time. I just want to, because the paper also says some other thing, like basically if we were to grant the Mendelian randomization outcomes, there would be another interpretation to be made, which does not seem to make LDL-C look like the cause. So I can screen share it here.
Okay.
So here, However, the magnitude of exposure to LDLC shown by the x-axis in Figure 2 could be a surrogate marker or a synonym of magnitude of exposure to increased supply of LDL carried lipids to arterial tissues. The basis for this interpretation is as follows: most, if not all, wait, I'll mark it. Most, if not all, SNPs that were found to be correlated with CHD are related to steps involved in LDL apolipoprotein recognition of the LDL receptor, LDL receptor processing at the membrane, internalization and lysosome fusion, and reutilization of the LDL receptor. When these steps are altered by mutation of the related genes, LDL-C levels rise, supply of LDL carried lipids to arterial tissues decreases, and CHD events increase. Or conversely, decreased LDL-C leads to increased supply of LDL carried lipids and subsequently leads to decreased CHD events.
Yeah, great. show some data. I don't know. Like it sounds good, but it's a mechanism.
I mean, but this is what we have. We have like the outcome evidence, and then we have different interpretations. Like we have different ways of explaining it. So with the evidence we have, this might be just as good as your interpretation, or
well, to me, what like with what that is saying, I just don't understand. Like, what's the point? Who cares about all this other stuff going on if we know that a gene that gives you lower LDL reduces risk? That's all I care about, is like lower LDL reduces risk. That's the whole point. And so it's like, if there's all this other stuff going on, like, okay, I can grant it all, like if you don't disagree with the outcome data that's being shown here. So unless you're saying that there's outcome data that like is missed or something, we can look at that, but I haven't seen it.
There was the other butter study, but you haven't looked at that, so I won't hold you up on it.
Yeah, and just so I know what to look at, so that was the dairy study, and the interesting thing there, which I am really interested to look at, is you said the butter consumption went way up and the risk went way down.
Yeah, for specifically in the case of stroke and in the case of major adverse coronary events and coronary heart disease, there was basically no association.
Okay, no association with coronary heart disease. What? How much more butter a day? And
if we look at the graph, it goes up to well over 150 grams a day.
Okay, cool. Yeah, I will gladly check that out.
Yeah. I'm trying to think of something. Do you have anything that you want to get cleared up or elaborated on?
Well, you provided a bunch of references also. We went through, and I apologize. I would have prioritized going through the dairy one if I would have known. The couple that I went through was the one you just talked about, the critique of the European Consensus Statement atherosclerosis. Oh my gosh, society.
Yeah.
I went through that one. A lot of it, it's huge. So I went through like, I don't know, half of it probably, and I have a lot of issues we can talk about. We've talked about some of them where we disagree. You brought up the Ufi Ravenskov paper, which I was just probably good that you didn't bring it up because it's just riddled with errors. I don't know. Have you?
Yeah, I've seen like the typical response, like some article a guy made about it, which I would say he has pretty fair critiques. My main thing with this was the main thing I would have used it for would be with the statin trial and just Mendelian randomization. They mention some problems with Mendelian randomization and with the statin trial. And there are some other things that I would grant that there would be some problems with it. I think many of these studies are too quickly to do some arguments that are kind of iffy. Like one of the studies I provided said that people with familial hypercholesterolemia didn't have a higher risk of coronary heart disease as with higher ages. And when I looked at the reference they used for it, it was like a difference between 6 events and 8 events. Or like 8 events would be the expected deaths, and 6 events was what they observed. And I was like, well, that doesn't really show the thing you want to show. So I can agree that some of the studies I've mentioned, they definitely have points that would be that could be disputed easily.
Yeah, and fair enough. Like I'm not going to just like pull the links out and just like trash things that you're not wanting to bring up. But is there anything else you wanted to bring up in particular?
I mean, it's not something I have prepared for. So
Well,
it's just like a minor point, but it's basically that people generally, we see an association between higher LDL-C, people living longer.
We see, yeah. Well, like,
and then there's the
ecologically,
thing
you
with
mean?
I don't think this is actually ecological, but the typical response is reverse causation.
Right, like the people are being in third world countries are getting insufficient nutrition. Like that's
No, this is not with this is not in regards to like ecological. This is within a certain population.
okay.
But I can share with you the most common counter argument for your side.
I don't even know what you're talking about yet. So
Yeah.
feel free to, like if it's data that, like if you don't believe in the argument, like let's not even go there. But if
I do believe in the argument.
Okay, go for it.
But I mean, I don't know if I want to go too deeply into it because I did not prepare for it, because to show the point correctly, I would need a bit more studies than just one.
Yeah, well, maybe that could be I was going to
Yeah.
say maybe that could be a thing that, since you guys were talking about a second talk, that
Yeah.
you could send that information to Michael and then you guys can read ahead and plan. I don't want to cut you guys off if you want to do that. I do have a question for both of you guys, but I didn't want to do it in the middle of this. I wanted to wait till you guys felt like you were done.
Mhm.
Sure.
Yeah, so I can just quickly say what the claim is. So basically, that within the same populations, not between countries, but within people in the same country, for instance, there's an association between people having higher LDL-C and living longer.
What countries?
I don't know which country the study is done in. Method.
Do you think that that's true in North America?
I don't know.
Or Europe?
I'm not sure. Here it says, I see a country. I see one here. In addition, numerous Japanese studies have found that high LDL-C is not a risk factor for CHD mortality in women of any age. But that's not the claim I was looking for. No, as I said, I haven't really prepared for this point specifically, but it's just something you can prepare for, because I'm probably gonna bring it up for next time.
That's totally fine. If you wouldn't mind just sending like whatever data you'd like me to look at before going through that, that'd be great.
Yeah.
Carson, maybe before we go to questions, Oliver, if you have anything else you want to say also, but like I have one more thing too.
You just start. I'll see if I.
Yeah. Well, mine is basically just a recap. So I'm just going to show this again. I'm getting faster at the share screen now. So this was where sort of my causal inference. So again, we have ApoB causes heart disease. Red meat causes ApoB and has saturated fat, which independently causes ApoB. Did I say? I think I said it right. Anyway, and then when we zoom out, we see saturated fat is associated with heart disease, and red meat is associated with heart disease and death as well. And we have we didn't get into Zong too much. You had a few issues with Hooper, but it's still, you agreed it was leaning in that direction. I think you said you didn't disagree with the Clark or the Bergeron that saturated fat and red meat cause ApoB, but you did have some issues with ApoB causing heart disease.
Yeah.
Being causally associated with heart disease. Is that a fair summary of kind of where we got to?
Yeah.
Yeah. All right. So
I'll say so. Oh, wait, did he
Uh-oh.
just go?
I think he accidentally clicked out. And
Yeah,
yeah.
wrong button, I think.
All right. I'm sure he'll be back in just 1 sec. And then let's see. Hopefully he didn't lose his internet or like lose his power to his
Yeah,
laptop.
that would be unlucky. But he should be able to write over the phone then
Yeah.
in the Facebook group if he lost his power.
Yeah. There he is. Hello.
Welcome back.
probably guess what happened there.
All right. Gotcha. Okay. Are you guys ready for a question?
Yeah.
Okay. There is a question in the comments over here, but I'm actually going to send that to you guys separately for the next talk. But I just have a personal question for you guys, and this will be for both of you. But we'll start with Oliver. Considering the concerns with at least one of the studies or some of the studies, as far as the sugar aspect and all that, can you describe what a study or multiple studies, like a meta-analysis or a cohort study, would need to look like for you to change your mind on the topic being talked about today? Like how many people, what would have to be factored in?
Yeah, okay. So there are different ways you could do it for me. First of all, I think it should relate to someone on a hypercarnivorous diet. So what I think about that, what I mean by that is the study should look at, for instance, people on animal-based keto diet, for instance, with no seed oils and at the very least like a very high meat consumption and not that much of that other stuff, and then compare that with the other groups, because what my concern always will be, even if like we have perfect data gathering, we know exactly what these people eat, and we perfectly understand what is happening, or what happened in the study. I would still need to see that this applies to someone in my context, because as I said, it might be that LDL is bad if you eat a bad diet, in which case that would be reflected in the outcome data. But it might also be the case that it's not bad in the case that you eat a clean diet, or what I would consider clean, in which case we wouldn't really know from the outcome evidence. Is what I would say. So it would probably be like a study which actually included people, eating low
Okay.
carb, low seed oil, a lot of meat.
Would there need to be a certain number of people in the study, and how long would it have to be followed for you to feel confident?
I can't name an exact number, but I would probably close up on a decade. Depends on the outcome we're looking at. But if it's like all-cause mortality or heart disease, I would probably say around a decade. And it also depends on like how strong the effect size is. So if we have like a 0.01% increase in risk, I wouldn't really consider that significant. So it depends on a lot of things, and then the sample size, I don't know, 1,000 maybe.
Okay.
Can I ask
and then
a follow-up question to that?
yeah,
Or-
yeah, definitely, yeah.
So, we didn't really get into this, but in the which one was it? The Pan-Sun meta-analysis, which took into the combined nurses' health follow-up study, or the nurses' health and the health professionals follow-up study. I can flash it on the screen if it's helpful, but there was a dose response curve from red meat intake with risk, and it was like a fairly strongly associated and a fairly high relative and absolute risk. So is your position that like those curves are fine, but if you eventually at some point, in which we don't have data for, but if you kept going up, eventually at some point it would drop off? Is that what you're saying?
That would be one possibility. I don't actually. Oh wait, it depends what you mean. There would be one interpretation, yes, but what I would say is basically you could keep the same meat intake, for instance, but if you remove something like seed oils or all the processed stuff, all the things I would consider to be bad, and replace it with something, it doesn't have to be meat, then the risk would also go away. So it's not like you eat more meat and the risk gets better at some point, but it's just that it's not the meat, it's what else you eat, is what I'm trying to say. And when you get up to eat like 80% meat, naturally you don't eat that much of other things.
So yeah, it's very strange to me in that like we have studies where they isocalorically replace red meat, like we showed the ones where they replaced red meat with polyunsaturated, or sorry, with a bunch of things, like there's chicken and fish and beans and vegetables and everything, and there was a reduced risk in those cases that was dose response dependent on how much meat was reduced. So when you see, like, it seems weird to me to expect that like at some point there'd be like a drop off, because when we see that the risk is associated with the meat consumption, I get that like it's a replacement diet, so you're maybe removing other things that might be a problem, but you're removing those things even in the doses we are tracking. So why would it change like beyond a certain threshold?
I'm not necessarily convinced by that. You said dose response, but I don't know if it's from the same study you're quoting, but you showed one with it was split up into 4 quartiles.
Yeah.
And it basically showed the first 3 quartiles, it was like higher risk, a bit lower risk than the first one, and then same risk as the first one. For the first 3 quartiles, it was basically like 1.16 relative risk, 1.0 something, and 1.17. And then went up to 1.36
by the 5th quartile.
Yeah. Though. So that doesn't sound like a dose response relationship to me.
Really?
Because it started relatively high, I would say, then went down, then went up to before, and then went up again.
Well, it was trending upwards through, and it's like it had a bit of a tapering and then continued.
I have a question actually. Do you know how much the intake was for the 4th quartile?
Yep.
How many grams per day was it?
I'm gonna have to look, but I can definitely look.
Because I remember I have seen another study like it where they studied Japanese people, and the highest quartile of meat eaters were like 200 grams a day. And for me, that's still very much on the low side.
Okay. This was from. Oh boy. This was from where? I'm looking. Do you remember which study that was from? I'm just blanking on.
I don't remember. It's either like the Pan-Shung study or either the Pan-Sun study or the Shung cohort. I think it's the Pan-Sun actually. I can look it through as well. Yeah, it's the. Oh wait. I need to check. I think it's the Pan-Sun, yeah. Well, now I'm actually not sure.
Yeah.
Oh yeah, it is the one. Yeah, so I can see it here. It says here for unprocessed red meat. Oh wait, that's the relative risk. Now I just need to find the intakes. Total red meat.
It was Pan-Sun, you said?
Yeah, Pan-Sun. I can't see where they have the total red meat intake. Oh wait, no.
No. What the heck? Q5. Do I have that in my notes? I do. Okay, here.
Oh wait, no. Oh yeah, I found it now.
Okay.
As well.
Yeah, table 3. And then
that's the risk, I think.
No, that's at the bottom. Or you're right.
Yeah. I'm looking at table 1 right now. I'm just trying to find I can see a fish servings per day, poultry. I can't see red meat.
You want to share, or I can?
I can also share, but I can't really find it.
Okay. I swear I pulled it up.
All right.
So
I
once
found
again,
here dietary intake. And these are the different things they show, but I can't really see red meat intake.
dietary intake. Scroll down.
I
At the
can't scroll
bottom.
any more down. Maybe
Um,
here. No,
Dietary
it doesn't
intake.
seem like. I mean, there would also. I can just see now there would also be like a confounding variable with the calorie intake between the groups. It seems that the lower quartile people also eat way fewer calories a day, which could also have an effect.
Yeah. I mean, it's not like they're over consuming calories in the high group either, though. If you're, yeah.
Well, but I think we can just
What's happening?
we can just look at this next time, or we can find it for next time.
Sure.
Then
And then,
we'll do it then.
Michael, did you have any details you wanted to ask him about what the study would have to look like for him to change his mind? And then also, aside from that, do you want to share what would make you change your mind?
Yeah, I mean, like, I feel like in this and anything, I'm convinced on the leaning of the totality of evidence. And like, I definitely, I go by the, like the evidence hierarchy. So I would value like intervention trials, including Mendelian randomization, but also just like metabolic ward stuff and analyses of those, assuming like I agree with the analyses, inclusion criteria and methodology and everything. Like, you have to look at the studies, but like that is like the highest tier evidence. But you also would want other stuff supporting any conclusions that you're drawing from that. Like, you'd want to see outcome data that tracks people over a long period of time and is consistent with the findings of that. You want to see like large amounts of people researched, good congruency of data across studies. Like, a lot of this stuff is tough because we have enough evidence in most researchers' minds that saturated fat is bad. And so we're not doing new like intervention trials where we feed people a bunch of saturated fat or red meat or anything, because like it's unethical. So it's like, it's very difficult to run these kinds of experiments. There's enough carnivore people in the world, I think, where you could probably do something. Like, it would be tough to randomize though, because it's like, for randomize, it's like you wouldn't be able to randomize that. You'd have to recruit out of already existing carnivores. Otherwise it's unethical to randomize into it. So there's like some issues with how you would collect the data, but how you would get there is in steps. So you would show like maybe if we looked at like the outcome data and there was enough that went in the other direction as well, that like started showing that people who ate more red meat had better health outcome associations and everything. This LDL thing you're talking about would be interesting to look at. Like, if that's something that would be like a point in favor of the other view. So I don't know. My view, just like I change it as I learn things, and I've just, from everything I've seen, it kind of all points for the most part in one direction, and that's how I've formulated my view.
I just want to say some short things to that. I'll add that if we look at a carnivorous population, for me, it would also be significant if we looked at just a prospective cohort study of carnivorous people, and then we found some association with heart disease, and that would be something I would take into consideration very heavily. Definitely.
Now, Oliver,
So
would that
if
be
there was just
would
like
that
as an
be
example
enough?
for that, if there was a sixth quintile that was like 80% of calories from red meat or something, and that tracked with the dose response, is that kind of the kind of thing you mean?
Yeah.
Yeah. Okay.
And I'll also just add one more criteria. I would say plausibility. should be one. So we can find an association between a lot of different things, but it also needs to be plausible. Like we need a plausible mechanism. For instance, ice cream sales might correlate very well with shark attack incidents, but there's not really a plausible mechanism for why eating ice cream or selling ice cream should increase shark attacks. So it's more like an association which don't really depend on each other. You know what I mean?
I know what you mean.
Yeah.
Did you see, what did you think of the proposed mechanism that I shared earlier?
I think it seems a little simplistic, but I don't think it's necessarily incompatible with what I think. Basically, what I think is it's the way oxidative modification influences heart disease. Basically, it oxidizes the LDL molecules, which leads to foam cell, which makes it get eaten by macrophages, and then there comes foam cells, and then the I just lost my words.
Yeah.
Yeah.
I'm familiar
I
with
think you get
the
it.
OXLDL
Yeah.
mechanism. Like the issue to like, do you agree that OXLDL drops when plaque forms?
I'm actually not sure. I've not seen evidence for that. I have not seen anything investigating that, so I don't know.
Okay.
But it should also be accompanied with the fact that basically even the European Atherosclerosis Society paper also mentions that.
Well, it
in their-
mentions it through the mechanism I'm proposing, which still involves OXLDL, but it's
Yeah.
the oxidation happens in the subendothelial space.
Yeah, that's also what I think.
Okay.
So,
But so you're saying that something other than just LDL being there would be impacting that oxidation?
I'm not quite sure what you mean.
In my mechanism, the oxidation happens. Just it's going to happen. There's not like if the LDL gets there, it's going to oxidize eventually, and then like from there, you're going to run into like plaques.
What I think, I know what you mean now.
Okay.
So what I will say about that, at least I watched the debate between Mohammed Alo and Paul Saladino, and at least what Mohammed said is that he talked to a hepatologist, and there seems to be evidence that the body can very easily like clean out reactive oxygen species from the blood, and it's not really a problem in normal circumstances. So what I think is the problem is maybe if you eat too many seed oils, then you get so much oxidation that the liver can't just as easily clean everything out, clean everything before they do too much harm, and then some of it is gonna go into the subendothelial space and oxidize the LDL.
Yeah, like the problem with that is that the that OXLDL is like when you factor out ApoB, OXLDL is not an independent risk factor in predicting cardiovascular disease and atherosclerosis. So,
do you say when you factor in or factor out?
When if you factor out, or well, if you adjust for ApoB, basically. Mm-hmm. So when you adjust for OXLDL, ApoB still correlates with risk. Like reduced ApoB has a reduction in risk. When you factor out ApoB and are left with OXLDL with ApoB factored out, there's no more association with risk. That's what we see in the outcome data. So
you can send that to me, and I'll take a look at it for next time.
Okay, I will
definitely
put a note down to do that.
Yeah.
And if you have outcome data that says otherwise, I would be very interested to look at any of that as well.
Yeah, I have found something on ApoB. It's not like one of the big things I've looked into, so I'll need to look more into it before I can talk on the outcome evidence and mechanisms.
Yeah, and just so anytime I'm like ApoB correlates very closely with LDL. LDL is like one of the main things that is associated with ApoB. Like there's VLDL and other apolipoprotein particles. LDL, I think in most people is like 90% of it. So it's like, that's why they correlate so closely, but in some people it's not 90%, it's 60% or whatever. And so like, it doesn't tie as closely to risk. Reason I'm saying all that is if you're looking at research that didn't happen fairly recently, it's all based on LDL, not on ApoB. So if you're not seeing like ApoB in the literature, that's probably why. But we've realized that there's a better marker. It's still very similar. LDL is still associated and causal, but the better marker is ApoB because it accounts for other particles as well.
Mm-hmm. Yeah. Oh yeah, I wanted to ask you one thing. You said the hierarchy of evidence is something you value a lot. I just want to ask a few questions regarding that.
Sure.
So at the bottom of the evidence hierarchy, it says that expert opinion are the lowest quality of evidence. Correct?
Sure.
Yeah. But the problem I see,
it would barely be on the evidence hierarchy for me. Yeah.
I mean, the problem I see with that, with putting the evidence hierarchy on a pedestal, would then be that the evidence hierarchy is in and of itself also just an expert opinion of what someone thinks. I mean, I would agree to it. I would agree personally with it most of the time. I do believe you can design prospective cohort studies better than some RCTs, but generally it would be a good rule of thumb. But I think it's a bit contradictory as well in that case.
What's contradictory?
The contradictory would be that, like, valuing, like, almost religiously.
Yeah,
valuing
I don't
it.
religiously value it. That's not my position. It's more of
So
a general.
You would agree that. So
you
you would agree that.
Design or an underpowered RCT, and I would value a prospective cohort that's well designed, bigger powerful. Yeah.
Okay. Yeah, that makes sense. Yep.
Yeah.
Then I don't think I have anything more to that.
Yeah, I think we're the same page there.
All right. Well, let's set up another talk soon with all the elements you guys wanted to talk about with the next one.
Mm-hmm.
Anybody watching this that caught anything you want to ask questions to Oliver and Michael, put it in the comments, and I will likely get that to them before the talk. That way that can become part of the planned talk. But yeah, thanks for watching, everybody. And Oliver and Michael, you guys have a good one.
Yep. You too. Have a good day.
All right. Take care.